If you've ever flown into Chicago's Midway Airport, you may have noticed this from the plane. Or maybe this. These are former rock quarries turned reservoirs, and they're part of Chicago's Tunnel and Reservoir Plan, better known as the Deep Tunnel Project, a decades-long, multi-billion-dollar infrastructure project of a massive scope. But what function does the Tunnel and Reservoir Plan serve? And how does it work? Let's take a deeper dive into Chicago's Deep Tunnel Project. Since its founding, Chicago has always had challenges dealing with water. Built atop marshy land that was barely higher than Lake Michigan itself, the young city dealt with regular flooding and the inability to properly drain sewage from the low-lying terrain. Standing dirty water was commonplace in city streets, which was a public health risk, and spread disease like cholera. In the 1800s, the city would embark on a series of engineering schemes to alleviate these issues. First, with the raising of city streets by a couple of feet, and in some cases 8 to 10 feet above the existing ground level, allowing for a modern sewer system to be installed with adequate vertical height to drain properly. Evidence of the raised streets is still visible today in neighborhoods like Pilsen, where it's common to see buildings built before the street raising, their ground floors now well below street level. By the late 1800s, the Sanitary District of Chicago was established, who oversaw the construction of the Chicago Ship and Sanitary Canal, which effectively reversed the flow of the Chicago River, allowing wastewater to flow down the canal toward the Mississippi River, rather than into Lake Michigan, where the city's drinking water is sourced. And later, in the early 1900s, treatment plants would be built to purify sewage and wastewater before it was released back into city waterways. But despite engineering solutions like this, Chicago still struggled with its water problems into the 20th century, particularly during large storm events, which would cause flooding and overwhelm the city's sewer system, inundating it with more water than the treatment plants could handle, and leaving nowhere for wastewater containing raw sewage and polluted surface runoff to go, except directly into the city's waterways. By the 1960s, these sewage overflows were happening on a regular basis, around 100 times a year. So the Sanitary District of Chicago, which had changed its name to the Metropolitan Water Reclamation District, devised another elaborate engineering solution, the Tunnel and Reservoir Plan, now better known as the Deep Tunnel Project. Essentially, the Deep Tunnel Project is a secondary sewer system, a series of large tunnels connected to large reservoirs, intended to capture and redirect sewage and stormwater that overflows from their primary combined sewer system. Over the following 4 decades, the system has been slowly built out to include a total of 110 miles of tunnels, which range from 8 to 33 feet in diameter and are positioned 150 to 300 feet underground, deep enough to capture overflow wastewater and divert it into reservoirs. There are 3 reservoirs in total that are part of the Deep Tunnel system, and they're strategically placed on the north, west, and south sides of the city. Thornton Reservoir, located in South Holland, McCook Reservoir in Bedford Park, and the Majewski Reservoir in Elk Grove Village. These reservoirs are massive, with the ability to hold billions of gallons of water, and they're meant to be a holding location for untreated water until nearby wastewater treatment plants have time to catch up and process it all. Building reservoirs of this size in an urban area like Chicago is a logistical nightmare, which is why the Thornton and McCook reservoirs are actually former rock quarries that have been repurposed for the Deep Tunnel Project's use. The project has been coming online piecemeal. Currently, the system has the capacity to divert 11 billion gallons of wastewater, and when it's fully complete, with the opening of an expansion to McCook Reservoir, its capacity will be 17.5 billion gallons. The Deep Tunnel Project has been generally successful in mitigating flooding and protecting Chicago's environment, by reducing the amount of untreated wastewater released into waterways. And the project has also served as a model for similar projects worldwide, like the Thames Tideway Tunnel in London, and Singapore's Stamford Diversion Canal and Detention Tank. But in the decades since the project's completion, there has also been a shift in philosophy of stormwater management, favoring more natural solutions like green stormwater infrastructure. Chicagoland, like other heavily urbanized areas, is dominated by paved impervious surfaces that cannot absorb water and instead force it into sewers. On the other hand, green stormwater infrastructure utilizes natural systems like native plantings and bioswales, which can hold and filter stormwater naturally and in place, reducing the strain on sewer systems. In recent years, Chicago has made some strides toward implementing green infrastructure, and thus reducing its reliance on mechanical infrastructure, like the deep tunnel system. But the deep tunnel system is still doing the heavy lifting in keeping Chicago's water clean and safe, standing as a testament to the bold and big thinking that defines Chicago. It's a massive and essential system for the city, and it's one that's nearly invisible, hiding deep beneath Chicago's surface.